Hello everyone. In this lecture, I will be discussing the analysis of clocked sequential circuit. Before starting with the analysis problem, I will discuss few definitions related to the sequential circuits. So we'll start with state equation. The state equation is an algebraic equation that describes the behavior of the sequential circuit. The state equation is also referred as the transition equation. The state equation specifies the next state as a function of the present state as well as input. State table describes the sequence of input, output, the present state and the next state in the tabular form. The example of the state table is shown in the figure. The state table consists of the present state, input, next state and the output. State diagram is a graphical representation of the information available in the state table. The example of the state diagram is shown in the figure. In the state diagram, each state is represented by the circle, and the transition between the states are indicated by the directed lines connecting the circles. The directed lines are labeled with two binary numbers separated by the slash. The first binary number, it represents the input, and the second binary number, it represents the output for the given input. Flip-flop input equations. We know that the sequential circuit consists of combinational circuit and flip-flops. The part of the circuit that generates the input to the flip-flops can be described algebraically by the set of Boolean functions referred as flip-flop input equations. It is also referred as the excitation equation. Output equations. The part of the combinational circuit that generates the external output can also be described algebraically by the set of Boolean functions referred as output equation. So we'll see the procedure for the analysis of the sequential circuit. The first step is to obtain the flip-flop input equation. Next, write the next state equation. For the D flip-flop, the next state equation is same as that of the D flip-flop input equation. Whereas for the other flip-flops such as SR, T and JK flip-flop, the next state equations are determined using the characteristic equation. Next, write the output equation from the given sequential circuit and fill the state table for all possible combination of the input and the state values. Finally, draw the state diagram. So consider the sequential circuit shown in the figure. The circuit, it consists of two flip-flops A and B. The input of the flip-flops, it is DA and the output is QA bar. The input of the second flip-flop, it is DB and the outputs are QB bar. X is the input of the sequential circuit and Y is the output of the sequential circuit. So first we will write the flip-flop input equations. DA. So this DA is the output of the OR gate. Here the AND gate output, it is QAX and the output of the second AND gate, it is QBX. Both the outputs are given to the OR gate. So DA, it is QAX or QBX. The input of the second flip-flop DB, it is the output of this AND gate. The output, it is QA bar and X. So next step is to write the next state equation. So for the D flip-flop, the next state equation is same as that of the input equation of the D flip-flop. So here Q plus it is equal to D. So QA plus it is same as that of DA, and QB plus it is same as DB. So next, writing the output equation. So the output Y is nothing but the output of this AND gate. So here the output of the OR gate, it is QA QB. So it is QA or QB. It is ANDed with X bar. So Y it is QA or QB and X bar. So next step is to fill the state table using the values of QA, QB and X. So these are the next state equation. So we'll start with the first case. So here there are two flip-flops. So we'll have two bits QA, QB, and the input X, it can be either 0 or 1. So totally we'll be having 3 inputs. So we'll be having 2 power 3, 8 combinations starting from 0, 0, 0 to 1, 1, 1. So we'll consider the first case QA 0, QB 0 and X equal to 0. QA plus it is 0 and 0 it is 0, and again 0 and 0 it is 0. 0 or 0 it is 0. So QA plus it is 0. Coming to QB plus it is QA bar it is 1 and 0. So 1 and 0 it is again 0. Coming to the output equation Y, it is for the first case Q it is 0. 0 or 0 it is 0 ANDed with X bar it is 1. So 0 ANDed with 1 it is again 0. So similarly use the next state equations and the output equation and fill the remaining cases for the state table. So this is the final state table for the given sequential circuit. So this table is another form of the state table. So we have written the next state for separately for x equal to 0 and for x equal to 1. Similarly, the output is written separately for x equal to 0 and x equal to 1. The information is the same, but it is another form of representing the state table. And the final step is to draw the state diagram. So the state diagram, the entire information in the state table will be represented graphically using the diagram. So here we'll be having 4 states 0, 0, 0, 1, 1, 0, 1, 1. And these states are represented by the circle. Right. So we'll start with the state 0, 0. So with the state 0, 0, for the input x equal to 0, the next state is 0, 0. With the output 0. And for x input is equal to 1, the next state is 0, 1. With the output y equal to 0. Coming to the next case, 0, 1. So for the 0, 1, with the input x equal to 0, the next state is 0, 0 with the output 1. And for the input x equal to 1, the next state is 1, 1 with the output 0. Coming to the third case, 1, 0. For the input x equal to 0, the next state is 0, 0 with the output 1. And for the input x equal to 1, the next state is 1, 0 with the output 0. So coming to the last case, 1, 1. For the input x equal to 0, the next state is 0, 0 with the output 1. And for the input x equal to 1, the next state is 1, 0 for the output 0. So this is the state diagram for the given sequential circuit. So we'll consider one more example using JK flip-flop. The analysis procedure is same. The only difference is that in the previous problem, we have given with D flip-flop where the next state equation is same as that of the flip-flop input equation. Whereas in this problem, the flip-flop, it is JK flip-flop. So the next state equation should be determined from the characteristic equation. So that is the only difference. So I'll quickly solve this problem. So this circuit consists of two flip-flops A and B, and the input of the flip-flop is JA, KA, output is QA, and for the second flip-flop the input is JB, KB, output it is QB, and the input of the sequential circuit is X. So starting with the flip-flop input equation, JA. So JA is nothing but QB, and KA it is AND of QB X bar. Here JB it is X bar, and KB it is XOR of QA X. So it is KB it is XOR of QA X. So we have, with this equation JA and KA and JB, KB, we have filled up this tabulation for flip-flop input. The next step is to write the state equations, right? So for the state equations, we need to use the characteristic table or for the characteristic equation. So for the JK flip-flop, with J equal to 0 and K equal to 0, the next state is the same as that of the present state. For J equal to 0 and K equal to 1, the next state is 0. And for J equal to 1 and K equal to 0, the next state is 1. And for J equal to 1 and K equal to 1, the next state is the complement of the previous state or the present state. So we'll consider one example here, JA, KA. So here JA, KA it is 0, 0. So when JA, KA it is 0, the next state is same as that of the present state. So QA plus it is same as QA 0 and QB plus is and QB plus it is given by JB, KB. So JB, KB it is 1, 0. For 1, 0, the next state it is 1. Similarly, fill all the remaining columns for all the possible combinations of the input and the state. So this is another form of representing the state table. So the final step is to draw the state diagram. Again here we'll be having 4 states 0, 0, 0, 1, 1, 0 and 1, 1. And for the input x equal to 0, for the present state 0, 0, the next state it is 0, 1. And for the input x equal to 1, the next state is 0, 0. So remaining values again plotted graphically from this state table. Thank you. Happy learning.